Question 6. This question is about pH. Pure water dissociates slightly. Delta H is positive 57 kilojoules per mole to power minus 1. Equilibrium constant Kc is that. Ionic product of water Kw is that. Explain why H2O is not shown in the Kw expression. Because H2O is almost constant. H2O is almost constant. Explain why the value of Kw increases as temperature increases. Well, we know delta H is positive, so forward reaction is endothermic. So if we increase the temperature, equilibrium will shift to the right hand side to minimize the temperature. So let's just type that down. The forward direction equilibrium is endothermic, hence equilibrium shifts to the right hand side to oppose the increase in temperature by decreasing temperature. Endothermic forward direction. Give the expression for pH. pH equals minus log 10 H plus equals minus log 10 H plus. So if we were trying to find pH, we need H plus, right? And we know that Kw is H plus OH minus. Kw is equal to H plus OH minus, right? Are we given anything information about OH minus? No, we're not. So what we can use is this equation. Kw is equal to H plus squared. And how do we find H plus? Well, we know H plus. How do we find H plus? H plus Kw is equal to H plus squared. And we know Kw at what temperature? 50 degrees Celsius is this 5.48 10 by 10 to the power minus 14. So we can say that H plus is equal to square root of Kw. Yeah, H plus is equal to square root of Kw, which is square root of 5.48 times by 10 to the power minus 14. Let's find out. H plus equals square root of 5.48 times by 10 to the power minus 14, and we get 2.34 times by 10 to the power minus 7, and therefore pH is equal to minus log 10 of 2.34 times by 10 to the power minus 7. So, which is 6.63. And then it says, explain why water is neutral. And like I said in the previous video in this playlist, maybe 2 videos back or 1, anytime it asks about why water is neutral on pH, it's because of this equation. H plus equals OH minus, and they're always usually 1 markers. It's worth 1 mark, and all you have to do is write down the equation. H plus capital square brackets is equal to OH minus, and pH is 6.63. Okay, and then it says pH meter is calibrated using a calibration graph. To create the calibration, the pH meter is used to measure the pH of separate solutions, each with a known accurate pH. Figure 3 shows a calibration graph. Use figure 3 to give the true pH value when the pH meter reading is 5.6. Let's zoom in a bit. When the true pH So we were trying to find true pH value, and the pH meter reading is 5.6. 5.6 is here, 5.6 here, something here. That's 5.1, 2, 3, 4, 5. It's not 6, it's in between 5.5, 5. And then suggest why the pH probe is washed with distilled water between each of the calibration measurements. So why would that happen? Why would we wash it? Well, to wash off any substance which could interfere with the reading. Which could interfere with the reading. And then 6.6, the calibrated pH meter is used to monitor the pH and the titration. Explain why the volume of sodium hydroxide solution added is smaller as the endpoint is approached. Why the volume added is smaller? To avoid missing the endpoint. To avoid missing the end point. And then it says table 6 shows data about some indicators. Student plans to do the titration again using one of the indicators in table 6, one of these indicators, to determine the endpoint. Yep, avoid missing endpoint. State why all 3 of the indicators are suitable for this titration. Well, it's because you look at this figure 4. All of these indicators have a pH range within the vertical, like within the steep part of the titration curve. Why they're all suitable? Because all of them have a pH range within the steep part of the titration curve, which is here onwards. And then 6.6, calculate pH of the final solution at 25 degrees Celsius. KW is that 5 marks. Well, first things first, let's find out the moles. Moles of sodium hydroxide solution, so OH minus equals 36.25 divided by 1000 times by 0.200, which is what? 36.25 divided by 1000 times by 0.200. 7.25 times by 10 to the power minus 3. 7.25 times by 10 to the power minus 3. Number 2, find out the moles of HCl. Well, in this case, what does HCl contain? HCl has H plus Cl minus, and really what we want is H plus. So technically we're finding out the moles of the H plus. So it's going to be 25 divided by 1000 times by 0.150. And the reason you might be wondering why am I timesing these? Firstly, moles is concentration and volume, so concentration times by volume. And the reason I divide by 1000 is because we need to convert this centimeters cubed into mole per dm minus cubed. So therefore we need to divide by 1000. 25 divided by 1000 times by 0.150 at 3.75 times by 10 to the power minus 3. Now what do we do? We've got the moles. Well, now we can find out the excess OH minus. How do we find that? Always a subtraction between two moles we've got. So excess OH minus is equal to 7.25 times by 10 to the power minus 3 minus 3.75 times by 10 to the power minus 3, which is 3.5 times by 10 to the power minus 3. 3.5 times by 10 to the power minus 3. Now what do we do? Well, we know to calculate the pH it's minus log 10 of H plus, right? So what we can do is, first things first, we need to find out the concentration of OH minus, because this is just the moles. This is not, that's all we've done with these three steps. All we've done is find the moles of OH minus. We don't want the moles, we want the concentration. Moles of concentration, volume concentration is moles divided by volume. Therefore, concentration, moles divided by volume of OH minus, excess OH minus, 3.5 times by 10 to the power minus 3 divided by the volume, which is what? Well, it's going to be the total volume, 36.25 plus 25. 36.25 plus 25 divided by 1000, because we want it in moles per dm minus cubed, and then we get 3.5 times by 10 to the power minus 3 divided by 36.25 plus 25 divided, well, 36.25 plus 25 is 61.25. So 3.5 times by 10 to the power minus 3 over answer times by 10 to the power minus 3, which would give me 0.05714. Okay, and now what can we do? Well, now we can find out H plus, and then we can find out the pH, because we know Kw is equal to H plus OH minus. Therefore, H plus is equal to Kw divided by OH minus. And we found out OH minus, the concentration, and Kw is given in the question, so we just substitute that in. So it's going to be, I'm just going to put in a calculator, because I've already gone through it with you guys, told you what needs to happen. And rearrange the equations, so I'll just put in the calculator. 1.0 times by 10 to the power minus 14 divided by concentration OH minus, which is 0.05714, which we worked out before. We get H plus H plus is equal to 1.75 times by 10 to the power minus 13. Therefore, pH is equal to minus log 10 of 1.75 times by 10 to the power minus 13. pH is minus log 10 of my answer, which is 12 point, how many, just says calculate final solution, so we'll say 12.76. And that is the end of question 6. So let's go through it. 6.1, H2O is almost constant, therefore it's not shown in the kW expression. 6.2, forward reaction, equilibrium endothermic, hence equilibrium shifts to right hand side to cause increased temperature by decreased temperature. 6.3, we know H plus is equal to 10 to the power of, actually no, we can't do that, because we don't have H plus. We know pH is equal to minus log 10 H plus. We want to calculate pH of pure water 50 degrees Celsius. Well, 50 degrees Celsius, kW is that, and we know kW is equal to H plus OH minus. And what do we need to find? To find pH, we need a H plus, minus log 10 of H plus. So H plus is kW divided by OH minus. However, we don't have OH minus, so we can use the other equation. kW is equal to H plus squared, and therefore H plus is equal to square root of kW. And we know kW is 5.48 times by 10 to the power minus 14. H plus is square root of 5.48 times by 10 to the power minus 14. We get H plus is this, and therefore we can say pH is equal to minus log 10 of 2.34 times by 10 to the power minus 7. pH is 6.63 to 2 decimal places. And then explain why water is neutral when, like I said before, when it asks about why water is neutral, use that equation. H plus is equal to OH minus, square brackets. Use figure 3 to give the true pH value, and pH is 5.6. Meter reading 5.6, draw a straight line, then draw a straight line down, and you get your value. Suggest whether the pH probe is washed with distilled water between the calibration measurements to wash off any substance which could interfere with the reading, or to wash off any residual solution that could interfere with the reading. Explain why the volume added between each pH measurement is smaller at the endpoint of titration approach to avoid missing the endpoint. All have a pH range within the steep part titration curve. And then this one, 5 marker. Find out the moles of OH minus. Find out the moles of HCl. In this case, H plus. And remember, sodium hydroxide is NaOH, so we don't times the mole by anything. Where previous questions I've gone through, it's like barium hydroxide, and because BaOH squared, we need to times the moles of OH minus by 2 because we've got 2 of them. But in this case, we don't have to do it. Moles of OH minus, moles of H plus, then do moles of OH minus. The excess, to find out the excess OH minus, is the moles of OH minus minus the H plus. 7.25 times by 10 to the power minus 3 minus 3.75 times by 10 to the power minus 3 should give us the moles of the excess OH minus. Now, we don't want the moles, we want the concentration. Moles is concentration on volume, concentration multiplied by volume. Total volume is 36.25 plus 25 divided by 1000 to get moles per dm minus cubed. We get the concentration of OH minus, and therefore we can find out H plus, because we know kW is equal to H plus OH minus. Therefore, H plus is equal to kW divided by OH minus. We've got kW, now we've worked out the concentration of OH minus. Substitute it in, we get H plus, and therefore we know pH is equal to minus log 10 H plus. Substitute H plus in, so pH is equal to minus log 10 of 1.75 times by 10 to the power of minus 13, and we get pH is 12.76. And that is the end of question 6.